This is the solution video for question 30 from part B of the 2019 ECAA paper. In this question, we're asked to consider two geometric progressions. The first one being 1, root 0.3, 0.3, 0.3, root 0.3, etc. And we're told the sum to infinity of this progression is r. And similarly, s is the sum to infinity of this geometric progression here, 1 minus root 0.3, 0.3 minus 0.3 root 0.3, etc. And with r and s, we're then told to find r minus s, and we're given 6 different numerical options for this. So, looking at this question, it's clear we're going to have to use the geometric series formula for infinite sequences. So, for that, we certainly are going to need to know the a and r, i.e. the first term and the common ratio of both these sequences. So let's note that down first. So we've got this sequence here, which is related to r, and we see that the first term is 1, and the common ratio, so 1 to root 0.3, r must be root 0.3. Then similarly, for our other sequence, 1 minus root 0.3, etc., our first term again is 1, and our common ratio is minus root 0.3. Okay, so that's good. We've got to find r minus s, so it'd be very useful to find r and s if we can, and indeed we can, because we know a formula to work out an infinite sum of a geometric progression. Namely, a over 1 minus r gives it. So for r, we have 1 over 1 minus root 0.3, and for s, we have 1 over 1 plus root 0.3, because we're doing minus root of 0.3. So this is our r and s, and now we just need to find r minus s. So where do we go from here? Well, let's put them on a common denominator. So it's times this numerator and denominator this by 1 plus root 0.3, and numerator and denominator of this by 1 minus root 0.3 to get this result. Now the top is very nice because the 1's cancel, and the bottom is 2 because it's a difference of 2 squares set up. So we have 1 minus root 0.3 times root 0.3, so 1 minus 0.3, so 0.7, and on top we've just got the 2 times the square root of 0.3. So this doesn't look like any of our multiple choice options as of now, but if we look at B and E, they're both pretty similar. So how would we get from here to here? Well, if we times denominator and numerator by 10, we match the denominator up certainly. If we do root 0.3 times 10, then we can bring the 10 into the root to be square root of 100 times 0.3. So basically we bring the times by 10 inside, and we get 2 root 30 on the top and 7 on the bottom. So we know we have option E as our answer, and so our answer is E.